Chemical nomenclature is part of the Flipped Learning in General Chemistry series. This video will teach you how to name basic inorganic compounds. After completing the assigned problems, you should be able to give systematic names to binary ionic compounds of both monatomic and polyatomic ions, as well as binary covalent compounds and oxyacids. Ionic compounds are made of oppositely charged pieces called cations and anions that are held together in the solid state by electrostatic forces. They're commonly called salts, and when dissolved in water, salts separate into their constituent ions. You can usually identify an ionic compound based on where its atoms are found in the periodic table. The cation is usually a metal, shown here in yellow, and the anion is usually a nonmetal, shown in green. Naming a salt like NaCl, where each ion is made of a single element, is easy. I'm going to do 4 examples here, and you should follow along with the periodic table. You give the cation first with its elemental name, and you follow that with the anion using the suffix "ide." Sodium chloride. Don't forget to include a space between the two words. The ionic compound CdS is named cadmium sulfide. Now let's work backwards. The name calcium iodide doesn't tell us the stoichiometry of the compound because it doesn't specify the charges on each ion, but we can figure it out from the periodic table. Calcium is in group 2, so we know it prefers a +2 charge, and iodine is in group 17, so we know it prefers a -1 charge. The formula for calcium iodide must balance these charges, so the correct answer is CaI2. 2 -1 iodides plus 1 + 2 calcium gives 0 net charge. In the case of lithium nitride, the nitrogen anion is -3 and the lithium cation is +1, so the formula is Li3N. Review the octet rule and ground state electron configurations if you need help figuring out the charge on different ions. Polyatomic ions are covalent molecules that happen to have a charge. They will always be found as part of an ionic compound along with an oppositely charged counterion. The names for polyatomic ions aren't systematic, but these ones are pretty common, so you'll see them a lot. Most are anions made up of oxygen plus one other nonmetal, like nitrate, sulfate, phosphate, or carbonate. There are a few examples of polyatomic cations like NH4+, which is called ammonium. Naming salts of polyatomic ions is easy once you recognize that they're present. My first 2 examples are sodium nitrate, NaNO3, and potassium sulfate, K2SO4. Notice the ending hasn't changed. I used the name exactly as written on the last slide. Again, the number of each ion is not given. Calcium phosphate must have 3 + 2 calcium ions paired with 2 - 3 phosphate ions to be electrically neutral. Phosphate needs brackets to show you're doubling the entire ion. My last example has 2 polyatomic ions, and the formula is NH4OH. No brackets are needed because there's only 1 of each ion. Next, we'll look at covalent compounds without a charge. These will be made of nonmetal elements that are held together by shared pairs of valence electrons. Binary covalent compounds are named in a very similar way to ionic compounds, but the stoichiometries are more flexible. Here I'm showing 4 different compounds of nitrogen and oxygen, and they can't all be named nitrogen oxide. So just like before, the first atom gets its elemental name, and the second gets the suffix "ide." But now I need to add prefixes to say how many of each atom I've got. N2O is named dinitrogen monoxide. Notice the double O is omitted. It's monoxide, not monooxide. By convention, the prefix mono is omitted entirely from the first element. NO is just nitrogen monoxide, and NO2 is nitrogen dioxide. N2O3, however, gets a prefix for both nitrogen and oxygen and is named dinitrogen trioxide. If you're wondering why I put nitrogen before oxygen, it's because of electronegativity. The more electronegative element is listed last and is given the suffix "ide." Finally, we'll look at a common group of molecules called oxyacids. They're compounds of polyatomic anions plus the nonmetal hydrogen. They're acids because they produce the hydronium ion when dissolved in water, and they're named a little bit differently. Hydrogen isn't explicitly mentioned at all. Instead, the suffix of the anion is changed from ate to ic, and the word acid is added to the end of the name. For example, HNO3 is nitric acid. Again, stoichiometry is not given because it can be determined by balancing charges. H2SO4 and H3PO4 are called polyprotic acids because they have more than one proton, but the names are just sulfuric acid and phosphoric acid. Okay, that's all the inorganic compounds we're going to name in this video, so now press pause and try these two on your own. First, decide if you're dealing with an ionic or a covalent compound, and then give a systematic name. SO3 is a covalent compound because it's made of nonmetals, and it's named sulfur trioxide. Remember, the mono prefix is not included for the first atom. Ammonium carbonate is a salt of 2 polyatomic ions. Ammonium is +1, so you need 2 of them to balance the -2 charge of carbonate. You need parentheses around NH4 to show that you're doubling the entire polyatomic cation. Don't forget to complete the problem set and read the textbook sections assigned with this video. You should come to class prepared to give names for both ionic and covalent compounds, and also write the correct formula if given a systematic name. Thanks for watching.